What'd you
Hi,
say?
Graham. Hi, Graham.
What'd you say, Nate Cappy?
I joke. We did it. Hi, Kevin.
I can subpoena your phones.
It's almost ready. I don't know. I feel like Apple was trying to be that type of stuff.
All right. So today, I was gonna do a little change of pace and do notes up here on the whiteboard. So, but since we have some absences,
Kevin. Come on,
video.
Kevin was He was? Yeah, he was in staff today. No, he was in my meeting hour, and all of a sudden he got out of the door.
Okay, so today we're going to talk about the representation of power series, basically some shortcuts of how we can write an equation into a power series. It's really what we're going to do today and a week. Today and tomorrow we'll focus on more of the one type. Don't want to give it away yet. And then Wednesday, Thursday, we'll focus on more like Taylor series. And that's when, I've been telling you about you're going to need to know like the shortcut for how to write e to the x as a Taylor polynomial and sine of x, cosine of x. Well, I'll give them to you, but then you'll have to remember.
Yeah.
Do we need to know that, like, we know how, are we adding it to our tool belt with password?
Yes. Are you making fun of my describing that you have a tool belt?
No, like, if you ever something that's like, substitution,
Okay.
like, trig integration, like.
You have a lot of tools in your tool.
I know, but do we need to know, like, we know those?
Pencil. A calculator.
All right. So, I want to write this as a power series.
Okay.
Okay? Spots.
You mean fun.
Where's the center?
Centered at 0.
Essentially negative
one.
x minus a 1 to the negative.
What is the first term?
Minus.
Oh boy. It's like a long division.
We're gonna need to find a couple terms and write it as a series.
It's like UD. Or it's parts with a
There he is.
Hi, Sean.
First person that actually counts.
Nope.
Okay, welcome, Sean.
I mean, technically no one walked through the door, so.
Your, before you leave, make sure you get your quiz. Before you leave, make sure you get the quiz in the back. Okay.
Yes.
We are going to perform some longer division. Do you remember how to do that?
No.
Oh, the board for the teachers would be so sad.
You maybe
Say, the target wants division, then they
Plus
give me a
one.
nice calculator.
Cool. Are you dividing?
This isn't. What am I
I don't
doing?
know.
Why does this look so strange?
Yeah, all I can see was, let's go.
1 divided by 1 minus x, maybe?
Yeah, that's right.
We
Holman.
done
Oh, that's got complicated.
It's a lower.
No.
negative.
Rewriting it, I don't know, it just seems like it'd be more work to rewrite it that way.
No, it makes sense.
I like it
Because
more
from
sex.
increasing x
But 1 minus squared is hardly on the Taylor polynomial.
So,
Negative x goes into that 0 times.
1 over negative x times.
well, let's think of this. You know what? Let's do it this way. This is going to make more sense. 1 minus x. 1 goes into 1 how many times?
Ones.
And then what do? We multiply and we subtract. We're left with 1 goes into x how many times?
X times.
We multiply to get x minus x squared, and then we subtract. 1 goes into x squared.
X squared times.
It's almost like a thing.
It's x to 10.
So 1 minus x times x squared. Are you remembering how to long divide? What are we left with? Okay, are you guys seeing a pattern?
Yes.
Plus x cubed, plus x to the fourth, plus x to the fifth, plus x to the sixth.
Ah, so we could write this as okay. So we're not going to divide every single time. Is there a relationship from here to here?
Yes. So, if we divide that by 1 minus x, right?
Geometric series.
Is this a geometric series? A number raised to a power
Yeah.
of n, right? How do we find the sum of an infinite geometric series? First term over 1 minus r. First term over 1 minus r. Okay, so what we can do, so we can think of this as first term over 1 minus r, and we can write it as our series n equals 0 to infinity of, what do we say, x to the n. Where is this centered at? It's centered at 0. And what is going to be our radius of convergence? And x will need to be less than 1. Okay. So our radius is going to be 1, centered at 0. Why did I automatically put parentheses around? We have a geometric series. It's never going to include the endpoints because that would make it 1. That would make your radius 1. Exactly. Okay, so let's have some fun. Same function. Now I want it centered at x is 3.
And then we'll just start at n equals 3.
Centered at x is 3.
Actually, x times 3.
Okay, so our radius, our r is going to need to be x minus 3, right? So we need to rewrite this. So this is x minus 3.
So it's minus 2.
1 minus x.
4 minus 6.
Okay, let's talk about how we're getting that 4. It still needs to be 1 minus x. We're not changing the value. So if this is minus negative 3, hold on.
Well, we changed the value already then.
Yeah.
Not 4.
Negative 2 is
Yeah.
It's 1.
8.
negative 2.
Oh.
You could rewrite it as 1 over 4 minus x.
So, I really don't want it centered at 3.
Yeah.
Can I change my mind?
E.
I want it centered at negative 3,
Okay.
which means centered at negative 3, that would be x plus 3.
4.
So now the 4 would work. I didn't read my negative sign very well. Okay, so we don't want to change the value, so we need something minus a positive 3 to still be 1. Okay, so we chose 4. Does this fit a over 1 minus r?
No.
No. We need to force it to fit that. How?
You multiply by 4.
Okay, we're going to multiply top and bottom by 1/4. so that we're still multiplying by 1, right? 1/4 over 1/4. So we have 1/4 over 1 minus x plus 3 over 4. Okay. So to write our series, geometric series beginning at 0 to infinity, our first term is 1/4, and then we have our r raised to the nth power. You can rewrite this since this is 4 to the first and technically 4 to the n. We can write this as x plus 3 to the n power over 4 to the n plus 1 power. You have less to write. Okay, we can just kind of switch things together if we have common bases.
You prefer that one?
Yeah.
Over the first one?
I would accept both probably, but you're going to probably see this one, like in a multiple choice type. Now let's talk about our interval of convergence.
And now it's gonna be like,
How are you getting -1?
Centered at -3.
Okay, so we're centered at -3, and if we look at this right here, we need x plus 3 over 4 to be less than 1, right? We need the absolute value of r to be less than 1. Do you agree?
yeah,
So our radius of convergence is,
-4.
okay,
Oh, wait.
radius of convergence is
Yeah.
4. Therefore, our interval of convergence is -7 to 1, is that what you said?
Yeah.
We will never have to include the endpoints
So it's
Geometric.
geometric.
because it's geometric. Yay. You don't even have to check the endpoints.
Yay.
I think that's probably what we should yay about. We don't have to do that work. Okay. Now I want a power series for g of x is 1 over 1 plus x cubed. Okay. Does this look like 1 over 1 minus r?
No.
If we change it to,
Minus the negative.
yes, 8 over 1 minus r. Okay. So when we write our series, we have our first term times r to the n. This is not how I would want you to leave it. I would want you to write it as an alternating series. So what we have is -1 to the n times x to the 3n. Oh, thank you. Interval of convergence. Nate, Kathy, what is it?
Well, I don't know.
Here there are.
Oh, and it's like 1, -1.
Yep. We need the absolute value of -x cubed to be less than 1. Right?
Yep.
So our radius of convergence is 1.
Yep.
Centered at 0, there's our interval. Okay. One more. Simple one. I want this function to be written as a power series centered at x is -2. I'm going to write c is -2, centered at c is -2. Okay. Is it going to do you any good right now to change that 5 to a 1?
No.
No. You first want to focus on getting it centered, and then you can worry about the 1 minus r. So we want this centered at -2, which means we need to write this as minus x plus 2. So it's going to go here.
Oh, 3.
We want 7 minus 2 to equal 5, right? Calc problems. We forget the simple stuff. Okay. So now what do we have to do with this? Divide numerator and denominator by 7. So we have 4/7 over 1 minus x plus 2 over 7. Okay, so our power series.
Oh, it's always going to be the same thing that you're talking about.
What did you say, Graham?
It's always going to be what you're talking about.
Okay, yes, this will be familiar to you.
Where you have to like.
Where you have to combine. We have 7 to the first and 7 to the n. So we have 4 times x plus 2 to the n over 7 to the n plus 1. That 4 can be written on the inside or the outside. It has no effect on the interval of convergence.
Oh, you mean like how it is for like outside the.
Or, yeah, out here.
Oh, got it.
Not inside the x plus 2.
Right. So it can be written here or here. Okay? Interval of convergence. What?
-9 to 5.
-9 to 5. Talk us through that, please.
Because it has to be less than 1, so you gotta have radius of 7.
How about it is described as this?
Yes. Sure. The radius is going to be 7, and then you do some math.
You need to explain a little better than that, please.
You gotta find out what x value will get you 7, and what x value will get you -7.
Okay, easier way to think about it, we're centered at -2.
Yes.
-2 plus 7 is 5. -2 minus 7 is -9. Don't overcomplicate it.
So if the 4 doesn't affect it, because if you did that, 14. Why doesn't the 4 affect it?
Because the 4 divides out
Okay. Right, that is.
Okay, some properties. Okay.
Oh, now we're gonna play Monopoly.
Nice.
Hey.
I call first place.
That's okay, now I don't know.
I want
When they do, you go back.
Okay, we have 2 series. If we have a function where there is a constant in front of x, then what we can do is we can plug that in to our x. And it gives raised to that n power as well. Okay. You may see it in your book as this. if that function is being raised to a power, then you can raise this to a power. If you have two power series that are being added or subtracted, you can combine them to be one series. What?
Let's switch over to.
Okay, you ready for some fun?
We weren't already having fun?
No.
Care to defend a series one more time? Well, I guess this is where it gets interesting.
Find interesting.
Quite interesting.
More complicated.
Complicated equals fun. Yay.
Oh,
Most of the time, just establish a relationship like that. You have to prove it first.
You guys watch the movie and discuss.
Right?
A whole bunch of people with Minecraft.
We could watch the movie as a class and just
Okay, that's.
Wait, is that a properties then?
Yeah.
Right.
show you my brain off.
Okay. What could we maybe do here?
Divide by X. You got Y, I got C, that's C3.
I suppose we could.
Yeah.
Okay, that means there's a better way.
Graham.
This.
So it'd be like 1 over X.
Well, actually, that was
N minus 1 over X.
Would
Graham just doesn't like my problem solving abilities.
Almost the problem of the age
would those denominators be nicer?
Not really.
I might go back and watch the video just to understand.
What is this called? I'm going to give you 90 seconds. Please figure out A and B for me.
I trust someone else.
Probably.
No, it's not.
Oh, shoot.
And what did you get for A? 1/2. And for B? Was one of them negative?
I got a positive on
Those
those.
should both be positive.
They should both be positive.
Yes.
Excellent.
See,
Because they're not the only one. They'd have to add up to one and if you subtract one from the other.
Okay, hold on. So we can now write h of x as 1/2 over 1 plus x, right? Plus 1/2 over negative 1 plus x. Or is that what we want?
No.
What should we do to this?
Divide by negative.
Okay, so I want this to be negative 1/2 over 1 minus x,
Yeah.
right?
Yeah.
And over here, I'm just going to rewrite this to minus negative x, just to help us out.
Wait, where did what's the negative one on the other one? So it switches.
Because this was negative 1 plus x, and we want 1 minus r in the denominator.
Okay.
Okay, so we have two series here. We have the series of 1/2 times negative x to the n plus the series of negative 1/2 times x to the n. Okay, so I'm going to move the 1/2 to the outside for now. This is an alternating series. Right? Okay. So now, can we combine these two? Okay, so first of all, I'm going to put a 1/2 on the outside. So we have the sum, negative 1 to the n, x to the n, minus x to the n, correct? So what I'm going to do is I'm going to write this as x to the n times negative 1 to the n minus 1. Okay? Surely there is a simpler way of writing this. Let's determine what this series is. We have 1/2 times. When we plug in 0, what do we get?
Zero.
Okay. When we plug in 1, negative 2x, right? When we plug in 2, when we plug in 3, are you seeing a pattern?
Yeah.
Okay. So,
And then multiply it all by 1/2.
okay. So it's really negative x minus x cubed minus x to the 5th, right?
Negative 1/2
Okay. Well, first of all, it's going to be negative, right? All of those terms are negative.
2n plus.
That's just going to be x negative 2.
2n plus 1 gives us the odd powers. 2n would give us even powers. 2n plus 1 gives us the odd powers. Jared, what's our integral of convergence?
Oh.
Yes, negative 1 to 1. See? Fun. Have to Okay, now here is where our properties can be more helpful than what you feel this was. If I had, I can't remember what I named it. Okay. If this was our function,
There. To go to the. Oh, because half the time they're going to cancel each other out, and half the time they're going to add together.
okay. When we plug numbers in, it was either going to be negative 1 minus 1 or positive 1 minus 1.
Okay.
So that's why we get 0, negative 2, 0, negative 2, 0, negative 2. Okay, so did we before have a 1 over 1 plus x squared cubed?
Yeah.
Okay, we decided that 1 over 1 plus x cubed was what?
Negative 1 to the n times x to the n.
Okay, so if we want 2x squared times 1 over 1 plus x cubed, essentially, right? Then we can take this power series and multiply 2x squared to it.
That'd just be the first term. The 2x squared, because
Right.
it's in the numerator.
Right. So this would become 2, which you can put inside or outside, x to the
5, no, 3 plus 2.
and negative 1. And it wouldn't change your interval of convergence. We're still centered at 0. Okay? So use that trick to your benefit. Would that have been nice?
Okay, it doesn't have to be.
Basically.
Well, that
Right.
wasn't what we did. K was inside the power. Like, if we wanted,
I'm trying to figure out which one is.
Yeah, that's just like changing the function to where it's rewritten as that.
this is like I'm multiplying something to the power series, right? Let me show you an example of the KX one. We know that 1 over 1 minus x is this, right? If I plug in an, well, okay, this is kind of lame, I guess.
29.
Like if we plug in a 3x here, then, okay, that would be an example. That property is going to be more helpful Wednesday, Thursday. Okay, now,
It's next Thursday.
Wait.
all right, coming back to this,
Back to reality.
He's already got some kids that he doesn't know.
well, 1 over 1 minus x cubed, how does that compare to that one?
X to 3x.
It's just going to be x to the 3n, which, I mean, you don't really need any properties to figure that out, right?
Right.
Right.
That would be the one where you have the n to the power. Okay, now let's work with some calculus.
What were we doing?
Calculus 1. Let's work with some calculus 1. Okay.
First semester, second semester.
Let's take a derivative, guys. That's calc 1.
Right.
We're doing another round of
Hey, and then
Okay.
the sixth one.
How does this relate to 1 over 1 minus x?
That's squared.
Yeah.
Okay. How else? Ah.
It's negative.
So if we take the derivative of 1 over 1 minus x, what do we get?
Negative
I I disagree.
Because you have a chain rule in there.
You have a chain rule?
Yes, oh, okay.
That's what I thought.
So, if we take the derivative of the power series, we will have that power series.
And x to the n minus 1.
Here's where you need to be careful though. Where are you going to begin?
1.
Can you begin at 0
No.
in that power series? No, you have to begin at 1.
So yeah, and I was wondering that on the quiz as well. So when you can't start at 0, do you just start at the next?
You start at the next one.
Why can't we start at 0? Just get 0.
No,
You get x to the negative 1.
0 over
Which
0.
when you plug in 0, it's not.
Right. We can't have negative powers. And if you think about it, this is 1 plus x to the first, or I mean x squared plus x cubed. So when we take the derivative, our first term better be, well, 0 doesn't matter, right? Plus 1.
If you
Okay.
take the derivative of all the
Mhm. Mm-hmm.
disappears.
So 1 plus x squared plus x cubed. Okay, so does that match this? When we take the derivative, we get 0 plus 1 plus 2x plus 3x squared. Does that match what we got for our power series?
Yes.
You with me? Okay,
So
last example.
if we're given that, we just have to recognize that that's a derivative.
Or,
Should we put that down?
Probably.
That's a really nice natural line. It's really nice.
And
Oh, on
thank you. Been writing for a few years now.
You could say
Your 10,000
season
hours.
pro. Yeah.
Let's take the derivative.
I like derivatives.
Okay. What function would be nice to compare this to?
1 over 5 minus x.
Okay.
1/5 over 1 minus x.
So if we take the antiderivative of this guy, we get the natural log of 5 minus x. Do you agree?
plus c.
This is true. That plus c is important.
So we take that.
Okay. So I would like you to find me a power series representation. We're going to put the negative out here. Don't worry about the negative for your power series.
Yeah.
Go ahead and find me a power series for 1 over 5 minus x.
Okay.
Okay, so we
Andrew, what's your power series representation?
X to the n over 5 to the n plus 1.
We agree? And because we have to divide everything by 5. So we would have 1/5 over 1 minus x to the 5th. So you have 1/5 times x over 5 to the n. Okay. It's going to be easier to write it like this so you don't have to worry about the chain rule. Okay? So now when we take the antiderivative
dx.
with respect to x, okay. Thank you. What do we get? X to the n plus 1 divided by n plus 1 with the 5 to the n plus 1 still there. Remember, everything with respect to x. Plus c. Still starting at 0, because this would give you an x to the first plus an x squared plus an x cubed. And then this, we can have some plus constant. We just don't know what it is.
Negative, right?
Ah, good point. Negative because of this guy right here. Okay. So your homework assignment.
Some real abstraction.
Yeah, you get to be a little bit creative. I thought some of you like being creative.
I took classes that didn't make me be. They hurt.
Okay, so this is your homework. These will be more of the straightforward problems. Towards the end, you'll get more of the creative problems, but it'll give you a little bit of direction. Tomorrow, we'll do some work in class that may be more on the creative side of these problems. Okay,
Is it 19 through 21 odd or 19 through 21?
19 through 21. Oh.
Yes, you can't.
Otherwise, she could have written 5 through 21 odd.
Why didn't you write 5 to 17 odd? Bye, Kevin.